We are going to start with parametric differentiation, okay, and they are of the form of some y is equal to some f of t and g, or x is equal to some g of t, okay. So usually the question comes like, what is dy by dx? Sorry,
Your board is not visible.
board is not visible. Okay, is it visible now?
Yes.
Perfectly visible.
Yes.
Okay, yeah, it is visible now, right?
Yes.
Okay, yeah. So you have to basically find dy by dx, okay, correct?
Yes, sir.
Okay, so now so they have given like, how do we find it? So they have written a theorem like dy by dx is equal to dy by dt upon dx by dt, okay. So this small d is actually a symbol for partial differentiation. Mm, is it visible clearly to you what I've written?
Yes.
Yeah. So this is the symbol for partial differentiation, okay. So it looks very simple, I guess. We can directly go to the problems, isn't it?
Yes, sir.
Yeah. So we just write it down here as like dy by dt upon dx by dt, okay.
Yes.
So we take some problem, and for the we are just referring to 11th 12th class textbook for state board, Maharashtra state board, okay. And we are referring to example number 1. So first, the first part they have given it as x is equal to, can you repeat?
X is equals to a
Hmm?
to t raised to power 4.
Okay, and y is equal to
2
hmm?
a
Hmm?
t raised to t square.
T square, okay. So they are asking us to find dy by dx, okay. And how do we find it out? We just write dy by dx is equal to dy by dt upon dx by dt, okay, is equal to, so when we are differentiating 2at t square by dt, we have to write it as 4at, okay,
Yes.
fine. And then upon a t raised to power 4, so it will be 4a t cube, right?
Yes.
Okay, so this gets cancelled, and the answer is equal to 1 upon t square,
Square.
correct?
Yes.
Yeah. So this is a very simple thing. uh, if they ask you an example, or if they ask you an exam, how do we basically solve these problems, so it's fairly very simple for you people, okay.
Yes, sir.
So let us take, we'll just take example number 4 here. X is equal to a theta plus sine theta, okay.
Yes.
I think you have noted it down, right? How is it written?
Yes, sir.
Okay. So they have given fourth one, x is equal to a theta plus sin theta, okay, and y is equal to a
A
1 minus cos theta, right?
theta. Yes.
Okay. Now here, as you can see, they are like functions of theta, right? So we write dy by dx is equal to dy by d theta upon dx by d theta, right? Okay.
Yes.
So if we do dy by d theta, we will get it as a sin theta, correct?
Yes, sir.
Okay. And if we do this, we get a into 1 plus cos theta,
Cot theta.
okay.
Yes.
This gets cancelled and we get it as sin theta upon 1 plus
Plus
cos theta,
cos theta.
correct?
Yes.
Okay. You can just verify the answer. What is the answer given?
Tan theta by 2.
Tan theta by 2. Okay. So can we like differentiate further, or differentiate, I mean to say simplify it further? So how they have come at the final answer? So they have written sin theta is equal to 2 sin theta by 2 cos theta by 2, correct?
Yes, sir.
Okay. And then how they have written cos theta? Cos theta is equal to 2 cos square theta by 2 minus 1, right?
Yes.
Okay. And then they have put this in this formula, okay. So
Yes,
this
sir.
1 and 1 will get cancelled, okay. And then here, instead of sin theta, they have substituted 2 sin theta cos theta, okay. And then
Yes.
and so I'm just writing it down here, 2 sin theta by 2 cos theta by 2, okay, upon 2 cos square theta by 2. I'm just not writing that one down because it is getting cancelled. This one and this one is getting cancelled, okay.
Yes, sir.
Yeah. So we are, and then this cos theta, and here it gets cancelled, and here it is only 1. So the final answer is here, that it comes to be sin theta by 2 upon cos theta by 2, okay. And this they have written it as tan theta by 2, okay.
Yes, sir.
So you have come to know that how they have arrived at the final answer, okay.
Yes, sir.
Oh, yeah. So you can just take, or solve the problems further, okay. Okay. And
Yes, sir.
yeah. So how do we go ahead then? Shall we go to the next section directly, or you want to take some problems from the exercises?
No, sir. We can go further.
We can go further, right? Okay.
Yes.
So they have we are arriving at this section 1.4.3, where they have uh, you know uh, they have told us to basically find the derivative of one function with respect to other function, okay. So it is as simple as this, that they are asking us to find out dy by dx, okay, and where y is also some f of x, okay, and x is also some g of x, okay.
Yes.
Okay, so how do we go ahead with this thing? So it is just f dash of x, okay. So this term equal to f dash of x upon g dash of x, okay.
Yes, sir.
So just one mind-boggling thought that might be coming in your heads is, what is the application of all this, right?
Yes.
So is like you haven't used calculus in your day-to-day life till now, right? Correct?
No, sir. Actually, only in physics for some few,
Yeah.
like the basic things, sir.
Yeah.
No
So
complex.
yeah, so actually, there are many complex theories, okay. There are many complex engineering problems. When we say engineering problems, the engineering problems can refer to, a wide range. Like there are some space exploration problems, there are some nuclear reactor problems, okay. There are some problems where you need to design complex shapes, okay. You need to design some complex electronic devices. So all this application of derivatives, partial derivatives, everything comes there, okay. So if you enter the first year of engineering, the first topic or maths one that they usually call in engineering is actually calculus, okay.
Yes,
So,
sir.
so there is no escaping calculus. Everything here needs to be very, very clear what we are studying. Okay. So we are not just studying from the exam point of view. Obviously, we have to score well in the exams, but uh, our next aim is actually, to dig deeper into concepts, right?
Yes, sir.
Fine. So it has got huge application. Okay. So just don't question every time that okay इसका तो क्या use है, नहीं बहुत ज़्यादा use है इसका. Okay.
Yes, sir.
So okay, so now we coming back here. We have been given two functions, y is equal to f of x and x is equal to g of x. Okay, so if we want to differentiate y with respect to x, we simply write it as f dash x upon g dash x. Okay,
Yes.
fine. So we just take the example number 1 here. Okay, I hope the
Okay.
board is visible.
Yes, sir.
Okay, yeah. So we just take the example number 1, uh, where they have given we have to differentiate 7 raised to x with respect to, what is it given, x square, correct.
Yes.
So how do they do that? They do that by simply, you know doing f dash x upon g dash x, okay. And where f dash x is, we need to differentiate 7 raised to x with respect to x and then x square with respect to x, okay, fine.
Yes.
So what do we get after differentiating 7 raised to x with respect to x? Can you quickly tell me?
7x log 7 means
7 raised to x log 7, okay,
yes.
fine. And g dash x is
G dash x is 7x raised to power 6.
no, this is x square.
Uh,
X
okay.
square is g
2
2,
2x.
okay, fine.
Yes.
So if you want to differentiate 7 raised to x with respect to x square, this is the answer we get, okay.
Yes, sir.
Okay, yeah. So I'm just taking this one example here, okay. Next example you just go through them, okay. uh
Yes.
yeah, so there the exercise is like very straightforward or very simple, I guess. You can, they have asked at some questions that you need to find a derivative at some particular value of theta, okay.
Yes.
Correct. So I'll just take that example, okay. uh, so there is one question, okay, where question number 2 and the third part of the question number 2, okay. So Are we on the same page? Third part of question number 2. X is equal to what? T square plus t plus 1. Correct?
Yes.
And y is equal to?
Sine
Y is equal to sine
pi t by 2.
pi t by 2 plus cos
Cos
pi t by 2. Correct? And now you have to differentiate dy by dx. Okay? Like you have to find out dy by dx, and then in the final answer you have to substitute t is equal to 1. Correct?
yes.
Okay.
Sir.
So let us, so dy by dx is equal to dy by dt upon dx by dt. Okay? Correct?
Yes.
Okay. So so after I find out the answer, okay, so here what will I get? Pi by 2
Pi.
cos pi. Okay, so it's like pi by 2 plus cos pi t by 2 plus or minus pi by 2 sine pi t by 2. Correct?
Yes.
Okay, so this is the dy by dt. Okay, and upon dx by dt. So what is it? 2t plus 1. Okay, correct? Yeah. So we have written it this way. Okay, and then what we do is we substitute in this particular thing. We substitute t is equal to 1. So they have asked us to find the value of dy by dx at t equal to 1. Correct?
Yes. Sir.
Okay. So we substitute t is equal to 1. So when we substitute t is equal to 1, this will basically be 0. Okay, and this will be pi by 2 minus pi by 2 into 1. Okay, so the answer will be minus pi by 2, okay, upon 2 plus 1, okay, or is equal to minus pi by 6. So this is the answer you get.
Yes, sir.
Okay, yeah. So the exercise is fairly very simple. Okay, you shouldn't be facing any problem, I guess.
Yes, sir.
Okay, so now there are something called as higher order derivatives. Okay, so do you want me to take it right now? Higher order derivatives.
Yes, sir.
Okay, so let us go to the example. Okay, so first let me tell you what do they mean by higher order derivatives. So just see, if it is y is equal to some f of x, okay, so y is some function of x, correct? Yeah.
Yes, sir.
So what is the first order derivative? First order derivative. So first order derivative is dy by dx is equal to, we write it as f dash x. Okay.
Yes.
Then there is called as a second order derivative. Correct?
Yes, sir.
Okay. So that is like d of dx of dy by dx, okay, is equal to f double dash x. Okay, or this we basically write it as we're differentiating f of x first by x, then again by x. Okay, so this is the
Yes.
second order derivative. Okay, so this we usually write it as d square y by dx square. Okay, fine.
Yes, sir.
Correct? Yeah. Now I'm just writing what is the third order derivative. So third order derivative is written here in the form of d cube y by dx cube, and here we write 3 dash 1 2 and 3 f, okay, or it is actually d of dx of d of dx of dy by dx, okay, okay, fine.
Yes, yes, sir.
Okay, yeah. So there are multiple orders of derivative, okay, so we keep on finding them till they become 0, okay, fine.
Yes, sir.
Yeah. So let us take the very first example, okay, the part 1 of the example number 1 solved example, okay, and they have given it as you know
X cube
plus 7
7x squared
hmm,
minus 2x
minus 2x
minus 9.
minus 9, okay. So they have asked us to find the second order derivative, right? So what is the first order derivative? So let us say this is f of x, okay. So the first order derivative is f dash x, okay, it is 3x square plus 14x minus 2, correct?
Yes.
Okay, and if we write f double dash x is equal to what? 6x plus 14, right? So
Yes.
this is my second order derivative, okay. Let us take example number 5 here, okay. So example number 5 I'm taking, it is sine
Sin log x.
log x, okay. So what is the first order derivative here? The first order derivative is cos
Cos
log x upon x. So this is my f dash x, okay, and this is my f of x, okay. So now how do we go? What is f double dash x then? I'm just expanding this denominator, this thing, dash line here, okay. This is x square, okay. Can you tell me f of x upon g of x का डिफरेंशिएशन कैसे होता है?
cos log x.
No, first we basically differentiate with denominator, the numerator we multiplied with the denominator minus the differentiation of the denominator multiplied by the numerator, okay. So when we have like p of x upon q of x, okay, और इसका अगर अपने को डिफरेंशिएशन निकालना है, so how do we do it? इसका रहता है p dash x q x, okay, minus q dash x px upon q of x whole square, isn't it? याद आया?
Yes, sir.
कुछ ठीक है ना, ऐसे ही करना है ना? Okay, so what is the differentiation of cos log x? Minus sin log x upon x, fine.
Yes.
And this we have to multiply it as it is x, okay.
Yes.
Minus d by dx of x is 1 dot cos of log x as it is, correct?
Yes, sir.
So इसको ऐसा किया इज इक्वल टू, ये कट गया, ठीक है, माइनस साइन लॉग एक्स, ठीक है, ओके, स्क्वायर को थोड़ा ऊपर लिखता हूँ मैं, minus cos log x upon x square, right? Fine.
Yes, sir.
So this is the final answer. Or you can just take the minus sign out and write sin log x plus cos log x. Okay. So is it the final answer? Can you just verify it? Yeah. If you see, this is the final answer. Correct? Do you want me to share the screen or no? You already have it, right? So there's no point in sharing the screen. You already have the textbook, right? Hello? Hello?
Hello.
Yeah, you already have the textbook, right?
Yes, sir.
Okay, so I did not share the screen, right?
No, 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 sir.
Oh, okay, yeah. So I guess we can stop here. Okay, you can just see the examples, okay, and try to solve the exercises. And in the next class, we will have any doubt solving session. Okay,
Yes, sir.
fine. So
Yes, sir.
shall I end the meeting?
Yes, sir.
Okay, yeah. Thank you.
Thank you, sir.
So this is a correction video actually. In the morning that we saw that y is equal to some f of t, okay, and x is equal to some g of t, and we have written that dy by dx is equal to dou y by dou t upon dou x by dou t, and I had written that this dou is a symbol for partial differentiation. Okay. So just to correct myself, we are not supposed to use this symbol here as of now. So this has got a separate engineering application where we basically have a function z is equal to some h of x comma y, okay, and where x is being introduced as a parameter, uh, uh, as a parametric function, y is being used as a parametric function of t. So this is some qt and this is some pt, okay. So we have here dz by dt is equal to we can write here dou z by dou x by dou t, okay, plus dou z by dou y dou y by dou t. So this is one application of partial differentiation that we have to see, but this is not in the current scope of our +1 +2 or JE mains. So we just limit ourselves to this thing, okay, where we make a correction that instead of writing dy by dx is equal to dou y by dou t, we have to write it as dy by dt upon dx upon dt, okay. So this is a separate application and this is currently in our scope, okay. This is currently out of our scope.